Hi, my name is Hana Lobsinger, and today I will be talking about financial math and economics in the airline industry, specifically how an airline prices their tickets. The airline industry is often frustrating and confusing to many customers. When you go online to look at prices of flights, you may have wondered why the prices fluctuate throughout the day or from day to day, and why would the price need to change for the same product? Then, when you're actually sitting on the plane, how could someone sitting next to you have paid a different price for the same product? Another question people often wonder is why airfares don't go down when gas prices do. Shouldn't the flight be cheaper for the airline to operate? I will aim to answer these questions and others during this talk. I will begin by giving the basics and some background of the industry, followed by a discussion of the factors influencing airline ticket prices, and I will finish up with a conclusion and discussion of future research. I want to start off with some of the basics to help you better understand the industry. I chose to focus on the airlines in the United States to keep things simple. I have come to find through my research that it is a very expensive, competitive, and complicated industry. It is currently considered an oligopoly, which means that there are a few major players that make up the entire industry. This is important because it affects the amount of competition and therefore the prices. An important distinction to make is the difference between a luxury carrier and a low-cost carrier. Examples of luxury carriers are Delta and United, who target the business traveler, and examples of low-cost carriers are Southwest and Spirit, who target the leisure traveler. The difference of these target markets are very important because they play a role in how the airline decides to price their tickets. Airline ticket prices are more commonly referred to in the industry as fares, meaning the price of travel one way between two locations regardless of the number of flights involved. Seats go on sale about 11 months or 330 days prior to departure and are subject to changes of demand over time. They are also updated about 10 times daily. The industry has changed drastically since it began. One important change that I would like to note is the Deregulation Act of 1978. This act took away government control over the industry and allowed the airlines to set their own prices and routes and allowed new airlines to form. After reading many research articles on this topic, I compiled this list of factors that affect the airfares. The list includes timing, both of purchase and flight departure, flight distance, competition, oil prices, and the market. I was unable to find an algorithm that sets the prices because, like any big corporation, airlines don't want to make this type of information public for fear of making their strategies too transparent. The first influencing factor on the price is when you purchase your ticket. It is generally cheaper to book a flight early. My research advised that you purchase tickets at least 1 month prior to departure for domestic flights to get this cheapest price, and 3 months early for an international flight. This seems self-explanatory. If you buy your ticket early, you should get a lower price, as the airline raises prices in the hopes that travelers, typically business travelers, will need to book last minute without a choice of the price. However, booking early doesn't always guarantee you a lower price. The prices change every day, and sometimes airlines will have sales closer to departure in order to sell the seats. I also found that the best days to book were Sundays and Tuesdays, and the worst day was Friday, which showed to be on average 13% higher than a Sunday. Some reasons for this were that sales often expire at the end of the week, and business travelers typically book at the end of the work week. The next factor I want to discuss is the time or date of departure of the flight. My research articles stated that if you book a flight that leaves on a Tuesday, Wednesday, or Saturday, the price should be cheapest. I decided to get some of my own data to try to prove these claims. In the chart shown here is the data I collected to see if this was true. I went online and picked the cheapest flight of the day for the 7 days of the week, May 8th through May 14th. I collected my data on April 21st, so these are the prices posted on that day at the time I checked for a flight from Chicago to New York. I looked at the websites of some of the major U.S. airlines and included some low-cost and luxury carriers. The airlines that most closely showed what my research told me were the ones I have highlighted here in pink: American, Southwest, and Frontier. Spirit's prices are significantly lower because the price only includes you and one carry-on item. Some errors and inconsistencies with this that I couldn't really avoid were the fact that certain airlines go into certain different airports than others, so the competition may be different and cause for the prices to be different. In addition, some of the flights were nonstop, but some airlines didn't offer nonstops that day. Also, booking a flight that leaves near a holiday is generally more expensive because of high demand. The prices may also depend on the time of day that the flight departs. As you might expect, less popular times of day to fly mean cheaper tickets. For an example, red-eye flights are usually cheaper. The next factor I looked at was travel distance. Flying a shorter distance doesn't always mean the price is lower, even though the operating costs may be lower, like less fuel and less cost for labor. Distance and costs are actually not linearly related, and that is shown here in this example. Both United and American showed more than double the price to travel from Chicago to Memphis versus Chicago to Miami, even though Miami is more than twice as far. I took this data that was posted on the same day for flights leaving May 10th in the evening to try to keep things consistent. Even though the flight to Miami might cost more in operating costs to the airline, they may charge more for the ticket to Memphis for a number of reasons. There could be not a lot of competition at that airport, which drives prices up. Ticket prices are also influenced by the competition in the industry, both between airlines and airports. After the deregulation, it became easier for new airlines to enter the market. This brought in the low-cost carriers like Spirit and Southwest, who charged lower prices and forced the luxury carriers to have to lower their prices at times to be able to compete. Then, more recently, the major airlines started to merge and buy out the smaller airlines. With fewer players in the market, prices went back up. Flights leaving out of different airports may be priced differently because of competition between multiple airports in one state or even a large city. On the other hand, a small airport like Moline is usually costly to fly into because not many carriers fly into it, which means there are fewer choices, less competition, so they can charge more. A very important factor, and the one where the economics comes in, is the market demand. If the demand for the seats on a plane is high, the prices will be higher because they are in a way more valuable to the customer. For example, if there is a big concert or business conference at a certain location, prices for those tickets will be higher. Pricing analysts take historical demand pattern data from specific flights that they have been running for years and combine that with forecasts of future demand to set the prices. In reality, most of this is done through computer systems. Take a look at the graph of a sample flight shown here. The x-axis represents the days before departure, so it starts with when the seat goes on sale 330 days out and ends at 0 when the flight would leave. On the y-axis is the number of seats sold. The red line shows the expected demand for this particular flight based on historical patterns from years of operating the flight. It starts out selling slowly because many people don't plan their trips that far in advance. The blue line represents demand that is higher than expected. The big spike at around 240 days could represent the announcement of a sporting event, conference, or something that causes demand to go up for that flight. In response to that, the IT systems that manage this process will automatically cut down on the availability of cheap seats or raise the prices. The green line represents the opposite, or the times when the actual demand was lower than expected for that flight. As you can see, the lines aren't straight, so this is a dynamic process. Airlines can somewhat control this by keeping many flights the same, so they can better analyze the patterns in demand. There are also cases when it is less cost-effective to fill a plane. Maybe passenger demand is low, and it may actually be more cost-effective for the airline to carry more cargo than paying passengers. Airlines can also cut routes and offer fewer flights in the day, which raises prices because there are less seats available, increasing demand. Prices may also depend on airline performance. If an airline has low customer satisfaction ratings due to poor arrival and departure times, or a scandal in the news along the lines of safety, customers may choose another airline. In this case, airlines may be forced to lower prices to attract customers. Next, I will be discussing how the airlines make their fare structures. This graph shows a basic demand curve, which is meant to show the relationship between the price of a product or service on the y-axis and the quantity demanded, which is the amount a consumer is willing to buy at that price, which is shown on the x-axis. If the airline sets one price, P1, for its tickets, which corresponds to Q1, quantity demanded, they generate revenue, which is calculated with the formula in the bottom left, revenue equals price times quantity, which is represented by the yellow area shaded. By doing this, they are only capturing some of the potential revenue. there are customers willing to pay more, and the lost revenue from what they would have paid is represented by the consumer surplus in the top red triangle. The bottom red triangle represents the customers who could not pay P1 for the tickets and chose not to travel, therefore generating no revenue for the airline. If the airline adds a lower price P2 with the quantity of tickets demanded Q2, by the law of demand, as the price goes down, the quantity demanded by consumers will go up. Similarly, if the airline adds a higher price P3, the quantity demanded will go down to Q3. I labeled these types of customers X, Y, and Z. With these three different price levels, the airline is able to generate the revenue represented by the purple rectangles in this example. This way, they are optimizing their revenue, and they only miss out on the revenue left over in the red triangles. A problem with that model is that a customer would most likely not choose to pay the higher price if they have the option of paying a lower price. This is solved with a concept called segmentation or price discrimination, which basically restricts the customers from easily choosing the lower price. With price restrictions like advanced purchase, where the customer must buy the ticket a certain amount of time prior to departure, this is due to their lack of flexibility in purchasing a flight. After seeing how the airlines include different price levels in their fare structures, I want to explain how they choose those price levels. Here is the concept of elasticity, which is represented by the formula of the percent change in quantity demanded divided by the percent change in price. This formula tells us a few things. If the elasticity is greater than 1, the demand is considered elastic, and a change in price will result in a greater change in quantity demanded than that price change. For example, if an airline decreases the price of a ticket and the quantity demanded of that ticket goes up by a larger percentage, revenue will go up. If the elasticity is found to be less than 1, it is considered inelastic, and a change in price will result in a smaller change in quantity demanded. An example of this would be if the airline decreased the price and the change in quantity demanded increased by a smaller percentage. Therefore, revenue would decrease. The price that an airline aims for is the one that results in unit elastic demand, which is where the change in price and quantity demanded are equal percentages and revenue remains unchanged. It is important to note that elasticity is not the same as slope, and it is actually always a negative number because of the negative slope of demand curve. This too is in reality done by computers that interpret historical data of demand to set the prices. Ticket prices are also affected by some fixed costs that airlines are subject to, like operating the plane and paying the people who operate it. The two largest costs for an airline are oil and labor. There are multiple operating costs that go into the price an airline pays to fly the plane. The most significant is oil or jet fuel. Contrary to popular belief, if we see gas prices go down, this doesn't always mean that airfares will go down. This is because of a concept called fuel hedging. Fuel hedging is a financial concept that airlines use in order to lock in the prices of fuel and eliminate the risk involved with the change in price. Labor is another major cost for airlines, and this includes wages for the in-flight and ground crew. Finally, I note that even though the government doesn't have full control over the industry anymore, they still get their cut of the ticket prices as well as the taxes included in the fares, and we must take that into consideration when thinking about what a ticket costs. Going back to my initial research question of how ticket pricing works, I found that airfares are determined based on many different factors, both external and internal to the airline. Pricing is a very dynamic process and is greatly affected by forecasting changes in the market demand and analyzing past flight data. One way I could have furthered my research or proved some of the claims that research articles made would be to collect more data and analyze it. Here is a list of my sources used for this project. Thank you for listening to my presentation.